here, dilations, similarities, and slope PFA review. So what we're going to do is we're going to go over what dilations, similarity, and do some review on the slope. So the first thing on your note sheet, it says dilation, and it has a blank. So dilation is a form of transformation that enlarges, so gets larger, or reduces the size of an object. So think about when your eyes dilate, they get smaller when they're in the sunlight, or if they're in the dark, they get larger to let more light in or try to seek out light. If you ever want to test it out, try turning off your bedroom lights and let your eyes adjust so that way they can see. That's a dilation. Your eyes dilate to let the light in so you can see. Kind of like night vision. Our next one here is similar figures. So two objects that have the same shape. So in this case, elephant, elephant. They're the same shape because the ratio of corresponding sides are the same. So something like a small elephant, if it was 5 feet high and the larger elephant was 10 feet high, it has a corresponding side by 5s. Okay, so that's what similar figures is. Same thing with soda. I could order a small, which is 20 ounces. I could order a medium, which is 40, or a large for 50 ounces. It's a lot of soda, but that type of similar thing. It's not changing the way it looks. It's just enlarging or making it smaller. So translation, it's a type of transformation that occurs when an object is moved from its original location. So such as bricks. There's a brick here, it moved here, still the same size, still the same shape. It's just moving around. So like my cursor was from here, now it's over here. It's still the same shape cursor, it's just in different places. Our next one here is rotation. So rotation means I'm taking an object and rotating it around a certain point. So if I was going to rotate my cursor from here to here or here to here, I would put a dot here and move it. So rotation, kind of like rotating a car or a Rubik's Cube, it's still the same shape, it's just rotating around a certain point. In a Rubik's Cube, it's rotating around the center. Reflection. Think about it. Look at yourself in the mirror. That's your own reflection. Yeah. Anyway, reflection is a transformation that occurs when an object is mirrored across a point. So if you see here, if I was going to draw a line, this is my original picture. It's reflected on the other side of this tree, it looks like. So it's not changing shape, it's not changing position, it's just basically flipping the image the opposite way. If you want to test it out, try writing something on a piece of paper and hold it up to a mirror. It should be completely backwards. So now what we're going to do is practice a problem. So Rebecca's Eiffel Tower figure is 15 feet tall and it's 10 feet wide. All right. So it's 15 feet tall and 10 feet wide. What Eiffel Tower is similar to Rebecca's figure? So similar, remember, it's either increasing the same amount on both sides or decreasing. So meaning multiplying to make it larger or dividing to make it smaller. So let's start here with A. Well, did that get any larger? No, it stayed the same. Well, and the bottom changed, but it's not changing consistently. 10 can't go into 6. So instantly I know that this isn't even an option. One side changed, the other did not. If we look at C, we'll just go straight down. If we look at C, what divided or multiplied by 15 will give me 3? 5. So if I divide the height, divide the height by 5, I should divide the width by 5 as well. 10 divided by 5 is actually 2, and 15 divided by 5 is 3. So guess what? C is going to be my option. But we always in math want to doubly make sure that we did our math right. So we got to check the other answers. 15 to 6. 6 can't go into 15. So that's instantly a no. D. Look what just happened. They essentially almost flipped it. 15 can't be divisible, or sorry, 15 cannot go into 10. Yes, it can go into 5, but if I divide it, I should get a 3, not a 10. Even though here, if I divided it by 2, I still would not get it. So we are in fact correct. Now, sometimes you'll have easy answers or questions like this, where it'll just ask you what's the difference between the height and the width. And sometimes you'll be given a quadrilateral. So let's look at our quadrilaterals. So there's some special triangles out there. I'm going to teach you about 2 of them. Angle-angle triangles. This means that 2 of the angles are the same. So as you can see here, this angle A and U are the same. So sometimes you'll have ones with lines similar to this. This just says angle 1 are the same. Angle 2 are the same. So it says 2 triangles are similar if 2 pairs of corresponding angles, so 2 angles, same side, are the same corresponding. We can compare the 2 corresponding angles. So if you see questions later on that have quadrilaterals or triangles and it has drawn right here and here and here and here or anywhere and has the same angle, then you can instantly know, hey, maybe I should pay attention to these a little bit more. They might be the same. There's also another one that's the same. Side, side, side. Meaning if the 2 triangles that I'm comparing to have proportional sides, meaning exactly the same increase or decrease, they are similar. So if I was going to take this side here, 15, it should be multiplied or divided by a number to get to 30. So in this case, I can multiply 15 times 2 and get 30. I can multiply 25 times the same 2 and still get 50. I can also multiply 20 times 2 and get 40. So I know that both of these triangles are similar to each other. They're multiplying each side by the same number. So let's actually practice some of these so you can kind of see what I'm saying. So our first question here is, a quadrilateral is shown below. Which figure is similar to this quadrilateral? So what we're going to do is pay attention to this side. We're going to pay attention to our 2 sides right here that are exactly the same amount. So I know that, hey, any quadrilateral that I see has to have these 2 sides have to be the same number. If they're not, it is not similar to my figure or proportional. Cool. So I'm going to look at my 2 sides here of my 6's. I'm going to go through and cross out anyone that does not have the same amount on the sides. So I'm going to start with A. Instantly, what do you think? Not an option, you're right. So this 8 and this 4, because it's positioned the same, are not the same numbers as my 6 and 8. So guess what? I can instantly cross this one out. Let's look over here. Okay, my 2 sides here are the same. So this is a contender. So upside down, because look, the smaller side is right here. Upside down, both of my 2 sides are the same, 12 and 12. All right, cool. So that's a contender. And same thing with D. The 2 sides are the same. So A was not an option. A can kick the boot. A is not my option. So now let's look at our side here for 15. Our top number should be divisible, either multiplied by a number, 1, 2, 3, 4, 5, 862, or divided by 1, 2, 3, 4, 5, any number that's divisible by. So in this case, 15 is only divisible by 3 and 5. That's it. So 15. What times or divided by will give me 14? No number at all. 14 and 15 are right next to each other. and 14 and 15 don't go into each other. So guess what? B is not my option. Now it's left to C and D. So since this one, C, is upside down, this 21 is what I'm going to look at, and this 7.5 for D, since it's sideways. So this 21, can anything, can 15 go into 21? No, not at all. 15 cannot go into 21. 15 times 2 is 30, so that's not an option either. Oh no. So you're thinking it has to be D. Well, let's double check and make sure. If I take 15 and divide it by some number, 15 divided by 1 would be 15. So now, let's try 15 divided by 2. If you plug it into your calculator, what do you get? 7.5! Yes, so don't get too excited. We still have to figure out if the other side is the same. If I divide this by 2, 20 divided by 2 is indeed a 10. And 6 divided by 2 will give me 3. So, yes, my final answer, my actual 100% answer is going to be D as in dog. Get ready for your next example.